A Thomson gazelle can run at very high speeds, but its acceleration is relatively modest. A reasonable model for the sprint of a gazelle assumes an acceleration of 4.2 meters per second square for 6.5 seconds, after which the gazelle continues at a steady speed. What is the gazelle's top speed? So, what we have here is a gazelle running, reaching a top speed, and then continuing at that constant speed. It accelerates at the rate of 4.2 meters per second square for a time period of 6.5 seconds, after which it achieves some speed we call VF, or final velocity speed, which is what we have to find out. We know our initial velocity as 0, so from acceleration equals change in velocity over change in time, we can infer that 4.2 meters per second square, which is our acceleration, equals our VF over our 6.5 seconds. So our final velocity, because our initial velocity was 0, final velocity equals 4.2 meters per second square times 6.5 seconds. Seconds cancel, and our final velocity is 27.3 meters per second, which is also our top speed. So the gazelle reaches a top speed of 27.3 meters per second. Now, the second half of the question asks us a hypothetical question. A human would win a very short race with a gazelle. The best time for a 30-meter sprint for a human runner is 3.6 seconds. How much time would a gazelle take for a 30-meter race? So basically the gazelle has not accelerated to its top speed. That's why the human would have won that race. So we can assume that the time period of this is less than 6.5 because the human has won the race, and it has taken the human 3.6 seconds. So since the human has won the race, we can assume that the time taken for the gazelle would be more than 3.6. That's why it lost the race, because the human, although it is not as fast as a gazelle, it can accelerate faster than a gazelle. So we use the position formula for the second half of the question, which is the final position equals the initial position plus the initial velocity times change in time plus half the acceleration times change in time, square of change of time. Our final position is 30 meters. Our initial position is 0, starting from 0 meters. This is a race. Plus our initial velocity as 0, change in time, plus half the acceleration, 4.2 meters per second square, times the square of change in time. 0 times something is 0, so that we can cancel. So 30 meters equals 2, and 4.2 divided by 2 is 2.1 meters per second square times square of change in time. So what we get is 30 divided by 2.1 meters per second square. This is meters here, the roots cancel, and this is a square root. Take the square roots to both sides to get change in time. What we end up getting here is approximately 3.8 seconds. So the time it took for the gazelle to run a 30-meter race is 3.8 seconds as compared to a human, which is 3.6 seconds. So the human won that race. Third part of the question, a gazelle would win a longer race. Okay, yes. The best time for a 200-meter sprint for a human is 19.3 seconds. How much time would it take the gazelle for a 200-meter race? So if a gazelle wins, we can assume that the gazelle takes less than 19.3 seconds. We use our position formula again, but let's try and figure out what's happening here. The gazelle runs for some time. It reaches its top speed because it accelerates for 6.5 seconds. Accelerates at the rate of 4.2 meters per second square as given. It reaches some distance, and after that distance, it continues along at a constant speed of 27.3 meters per second, which is what we found out in the first half of the question. And now, this is a race. This is a 200-meter race, so we know the distance is 200 meters. And we are asked to find out how long would it take for a gazelle to win this race. We know that it's going to take less than 19.3 seconds, which is what the human would take. The gazelle would win a longer race because it accelerates, reaches a top speed, and then continues at that top speed till 200 meters. So now, our first job is to find this distance out. We find that distance out with a position formula as xf equals our final position, this is our final position for now. Our final position is equal to our initial position plus our initial velocity times change in time plus half the acceleration, the square of change in time. We don't know our xf, we're trying to find that out. We know our xi as 0, we know our initial velocity is 0, and now half times the acceleration as 4.2 meters per second square times change in time, which is 6.5 seconds. So that gives us approximately, just squared, 88.725 meters. That's our distance. That's our distance at this point, 88.725 meters, after which the gazelle continues at a top speed of 27.3 meters per second till it reaches its final end point at 200 meters. So the distance of this part will be 200 minus 88.725, which gives us 111.275, which is our distance. And now we know that velocity equals distance over time, change in distance over change in time. We know our velocity as 23.7 meters per second, which is our top speed. We know our distance as 111.275 meters, which is what we found out, the distance right here. And we're trying to find out the change in time. So the change in time will be approximately 4.07 seconds. So it takes 4.07 seconds to complete this distance here, the final 111.275 meters, and it takes 6.5 seconds to complete the 88.725 meters. So adding up the 6.5 seconds with the 4.07 seconds, we get approximately 11 seconds. So the gazelle takes 11 seconds to complete a 200-meter race, while a human takes 19.3 seconds. The gazelle is faster in the long run, but slower by a fraction of a second in the short run.